Why does time move forward? You think you understand time, you've lived in it your entire life. Every second, every minute, every year flowing forward like a river carrying you from birth toward death. Okay, explain it to me. Why forward? Why does time move in that direction and not the other? Most people say something like, that's just how time works, or the past already happened. But that doesn't explain anything. That's like saying rocks fall, because they're the falling kind of rocks. You've just renamed the mystery. Here's what should terrify you. Every equation in physics works perfectly backward. Run the movie in reverse, particles bouncing, planets orbiting, light traveling, and the math doesn't care. Physics has no preference. Time could run backward and the equations would shrug. So why doesn't it? The answer connects your morning coffee cooling on the counter to the birth of the universe itself. And when you understand it, really understand it, you'll realize the direction of time isn't written into reality at all. It's an accident, a cosmic fluke. Let me show you what I mean. The standard explanation is that time just flows, like a river with only one direction. You learn it as a child. The past is gone, the future hasn't happened yet, and we're all riding the present moment forward. It's not wrong exactly, but it's completely backwards. We don't experience time flowing forward because that's the nature of time. We experience time flowing forward because of something else, something deeper, something that has nothing to do with clocks or calendars or the ticking of seconds. Once you see what's really happening, once you understand what actually creates the arrow of time, you realize the question isn't, why does time move forward? The question is, why was the universe born in such an outrageously unlikely state that forward and backward could ever be different at all? That question leads somewhere uncomfortable. Somewhere physics can describe but not fully explain. Somewhere that connects your fading memories to black holes, your cooling coffee to the death of stars, and your sense of now to the first moments after the Big Bang. There's a reason time has a direction. But the reason isn't what you think. Start with something simple. Something you already know but have never truly seen. Break an egg. Seriously. Picture it. You're holding an egg over a kitchen floor. You let go, it falls. It shatters. Yolk spreads across the tile in a messy splatter. You've seen this 1,000 times. You already know what happens next. Nothing. The egg stays broken. The yolk doesn't reassemble. The shell doesn't leap back into your hand. Obvious, right? Eggs break. That's what eggs do. But stop and think about that for a second. Why doesn't the egg unbreak? Every molecule in that shattered egg is still obeying physics. Every atom is still following the laws of nature. If you could somehow reverse the velocity of every single particle, send each fragment flying backward along its exact path, the egg would reassemble perfectly. Shell, yolk, everything. Right back into your hand. The laws of physics would not be violated. Not a single one. The math works perfectly in reverse. So why doesn't it ever happen? Here's the first layer. It could happen. There's no law forbidding it. The probability isn't zero. It's just so astronomically small that you'd have to wait longer than the age of the universe, longer than trillions upon trillions of universe ages, for it to happen by chance. The egg doesn't unbreak because unbreaking requires something almost miraculous. Every scattered molecule would need to spontaneously move in exactly the right direction at exactly the right speed at exactly the right moment. Breaking is easy. Unbreaking is astronomically hard. This asymmetry, easy to break, impossible to unbreak, has a name. Physicists call it entropy. And entropy doesn't just explain eggs. It explains everything. Why ice melts but water doesn't spontaneously freeze in your warm kitchen. Why perfume spreads through a room but never gathers back into the bottle. Why your coffee cools, but the room never heats your coffee back up. And here's the thing that should bother you. Entropy explains why you remember the past and not the future. But that's just the surface, because if entropy explains time's direction, we need to ask a deeper question. Why does entropy always increase? Let's make entropy simple. Imagine a box divided in half by a wall. On the left side, gas molecules. On the right side, nothing. Empty vacuum. Now remove the wall. What happens? The gas spreads out. It fills the whole box. Molecules that were concentrated on one side now scatter everywhere. This is entropy increasing, order becoming disorder, concentration becoming diffusion, special arrangements becoming ordinary ones. And here's the key insight. There are vastly more ways for the gas to be spread out than there are ways for it to be concentrated on one side. Think about it. For all the gas to be on the left, every single molecule needs to be in that half. That's one very specific arrangement. But for the gas to be spread evenly, the molecules can be almost anywhere. Billions upon billions of arrangements all look the same, gas filling the box. Entropy increases because there are astronomically more disordered states than ordered ones. The universe doesn't prefer disorder, it just stumbles into it because disorder is overwhelmingly more probable. This is the second law of thermodynamics, not a mystical decree, just statistics, pure math. Ludwig Boltzmann figured this out in the 1870s. He showed that entropy is really about probability. High entropy states are likely. Low entropy states are rare. And time? Time seems to flow in the direction of increasing entropy. The future is the direction where things get messier. The past is where things were neater. Your memory works this way too. Recording a memory increases entropy and your brain learns fire. Chemistry changes. Heat dissipates. You can only form memories in the direction of increasing entropy. That's why you remember yesterday and not tomorrow. Not because of anything special about time. Because remembering requires entropy to increase. But wait, if entropy always increases, if disorder always grows, that raises another question. If the universe is always getting messier, that means it used to be neater. And if it used to be neater than that and neater before that, how neat was it at the beginning? Here's where it gets strange. The second law of thermodynamics says entropy increases toward the future. Fine, but why that direction? Why not the other way? Remember, the fundamental laws of physics don't care. Run any equation backward, and it works perfectly. Particles don't know which way time is supposed to go. Neither does gravity or electromagnetism or quantum mechanics. The laws are time-symmetric. They're blind to direction. So the second law of thermodynamics, entropy, always increases, can't come from the fundamental laws. It has to come from somewhere else. Here's the thing most people miss. Entropy increases toward the future because entropy was lower in the past. That sounds circular. It's not. Think about the gas in the box again. Entropy increases after you remove the wall because the gas started concentrated on one side. If it had started spread out, there'd be no change. Nothing would happen. The arrow of time, the difference between past and future exists because the universe started in a state of extraordinarily low entropy, a state of improbable exquisite order, and then it's been falling apart ever since. The reason you experience time moving forward is because you're riding an entropy gradient. You're surfing a wave of increasing disorder that began 13.8 billion years ago. The Big Bang wasn't an explosion of chaos. It was an explosion of order. The most ordered state the universe has ever been in. And we're still falling away from it. Roger Penrose, one of Hawking's closest collaborators, calculated just how unlikely the initial state of the universe was. His estimate, 1 in 10, 10, 1, 2, 3, free. That number is so large it's meaningless. There aren't enough atoms in the observable universe to write it down. The initial conditions of the Big Bang were so improbable, they make winning the lottery look like a certainty. But that raises an even deeper question, one that physics can describe but not answer. Why was the Big Bang so ordered? Why did the universe start in such a freakishly unlikely state? Now we're at the core. And now we hit bedrock. The arrow of time is not fundamental. It's not written into the laws of physics. It's not a property of time itself. The arrow of time is cosmological. It's a consequence of initial conditions. The universe started neat, and it's been getting messier. That's the only reason forward and backward are different. They should break your brain. Every experience you have of time passing, every memory, every anticipation, every sense that the past is fixed and the future is open comes from one cosmological fact. The Big Bang was low entropy. If the Big Bang had been high entropy, if the universe had started in thermal equilibrium, everything diffuse and boring there would be no arrow of time, no past and future, no memories, no change, no you. And here's what makes this profound. We don't know why the Big Bang was low entropy. We can describe it. We can measure its consequences. But we cannot explain it. Some physicists, Hawking included, suspected the answer might lie beyond our current physics. Perhaps in quantum gravity. Perhaps in the no-boundary proposal, the idea that the universe has no beginning, just a smooth origin where time curves back on itself like the surface of a sphere. But here's what Hawking would tell you with that dry, unflinching honesty: we don't know. This is where the chain of explanation ends. Not because the question is meaningless, it's one of the deepest questions we can ask, but because we haven't solved it yet. What we do know is this: the arrow of time is not a feature of time. It's a feature of the universe's history, a fossil of creation, a relic of the Big Bang's improbable orderliness, and that means something startling about your everyday experience of reality. In your normal experience of the world, time flows forward like a river. The past is behind you, the future is ahead, and you're drifting along the current. It feels fundamental. It feels like the most basic fact about reality. The past happened, the future hasn't. Time moves from one to the other. Except that's completely backwards. Pause. Time doesn't flow. Time doesn't move. The direction of time isn't a feature of time at all. It's a feature of stuff, of how matter and energy are arranged, of entropy. The past isn't behind you because time passed. Time seems to pass because disorder increases, and disorder only increases because the universe started in a freakishly ordered state that may require explanation beyond physics itself. Let me prove it to you. Take any physical law, any equation. Maxwell's equations for electromagnetism, Schrödinger's equation for quantum mechanics, Einstein's field equations for gravity. Run them backward. Replace T with T. They still work. Every single one. The math doesn't break. The physics remains valid. This has been tested, measured, confirmed to extraordinary precision. At the fundamental level, nature does not distinguish between past and future. Only at the macroscopic level, eggs breaking, coffee cooling, memories forming, does direction emerge. And it emerges from statistics, from probability, from the overwhelming likelihood of disorder over order. Think about what this means. You don't remember yesterday because the past is fixed. You remember yesterday because remembering increased entropy in your brain. The neural patterns that encode your memories formed in the direction of rising disorder. You can't remember tomorrow because forming a memory of tomorrow would require entropy to decrease. And that doesn't happen, not because it's forbidden, because it's forbidden. Your entire sense of before and after the foundation of your experience, your identity, your life is a thermodynamic phenomenon, a side effect of probability. The arrow of time is not time's arrow. It's entropy's arrow. And here's the quotable version. The one that should stop you cold. The past is different from the future because the Big Bang was neat. That's it. That's the entire reason. The universe started in an improbably ordered state, and everything since has been falling apart. The direction of time is the direction of that falling. This isn't philosophy, this isn't speculation, this is measured, tested, confirmed physics. Boltzmann worked out the statistics in the 1870s. Penrose calculated the improbability in the 1980s. Hawking spent decades exploring the cosmological implications. The arrow of time is real, but it's not fundamental. It's emergent, it's cosmological, it's historical. And once you see this, you realize time isn't isolated. It connects to everything. Now here's what people miss when they learn just about time's arrow. Time isn't isolated. It's connected to everything. The same entropy gradient that creates your sense of past and future also creates your memories. You remember yesterday because recording that memory dissipated heat, increased disorder, and moved you along the entropy slope. No entropy increase, no memory, drives every living thing. Your body maintains order cells, organs, thoughts by exporting disorder into the environment. You eat low entropy food and exhale high entropy heat. Life surfs the entropy wave without drowning in it. Powers the stars. The sun burns hydrogen into helium, releasing energy and increasing cosmic entropy. Starlight is entropy made visible. Every photon is disorder spreading. Creates cause and effect. Causes precede effects because causes are lower entropy states. the match before the fire, the push before the fall. Causation is entropy's arrow in disguise, guarantees the heat death of the universe. In the far future, unimaginably far, entropy will reach its maximum. No gradients, no differences, no change, no times arrow, because no arrow remains. What looks like separate phenomena, memory, life, starlight, causation, cosmic destiny, is actually one thing manifesting in different forms. Entropy, rising since the beginning, pointing the way. You're not separate from this. Right now, as you listen, your brain is burning glucose and radiating heat. Entropy is increasing inside you. The very act of understanding these words, neurons firing, patterns forming, is a thermodynamic process, writing the cosmic gradient. You are a temporary island of order in a rising sea of disorder. You exist because the Big Bang was neat, and you persist by pushing entropy outward, buying yourself a little more time before the tide comes in. Your life is a local entropy decrease paid for by a greater universal increase. The books balance, they always do. That's not depressing, that's magnificent. You're not fighting time. You're made of time. Your memories, your anticipation, your sense of self flowing from past to future, these are entropy given form, given voice, given the ability to ask why. The universe began in an improbable state and is falling toward oblivion. And in that falling, it accidentally created something that can look back at the beginning and marvel. That's what you are. That's what time really is. So, why does time move forward? Now you know. Time doesn't move at all. The laws of physics are time-symmetric. Run them backward, they work fine. As the universe doesn't care which direction the movie plays. What we call the future is just the direction where entropy is higher. What we call the past is where entropy was lower. The arrow of time is not a feature of time itself. It's a feature of the universe's history. And that history has one extraordinary characteristic. It started in an improbably ordered state. The Big Bang was neat, unbelievably, inexplicably neat, and everything since every cooling cup of coffee, every fading memory, every dying star is the universe relaxing toward disorder. You experience time flowing forward because you're embedded in this relaxation. Your memories form in the direction of increasing entropy. Your sense of causation follows the entropy gradient. Your life runs downhill thermodynamically, even as you locally swim against the current. But understanding this isn't just about time. It's about what we can know, and what remains beyond our reach. 200 years ago, nobody understood why time had a direction. We felt it. We lived it. We couldn't explain it. Then Boltzmann connected time to probability. Penrose connected probability to cosmology. Hawking connected cosmology to the deepest questions about the universe's origin. And now we know. The arrow of time is real, but it's not fundamental. It's emergent, it's historical, it's cosmological. We still don't know why the Big Bang was so ordered. That's the unsolved problem at the bottom of everything. Hawking spent decades circling it. The no boundary proposal, the wave function of the universe, hints and guesses, but no final answer. The direction of your life, your memories, your anticipation, your journey from birth to death, ultimately traces back to a cosmological initial condition we don't yet understand. That's what time really is. Not a river flowing toward the future, not a dimension we move through. It's the universe remembering its own improbable birth, measured in the growing disorder it leaves behind. Not intuition, not philosophy. Truth. If this journey into time's arrow changed how you see your morning coffee cooling or your memories fading, subscribe and share it with someone who still thinks time just flows forward, because that's how time works. The universe is stranger than we assume, and the strangeness is the truth. What other everyday experiences do you think hide this kind of cosmic depth? Tell me in the comments. I read them, and some of them become future explorations.